The question number 18 is about synthetic substitution. Before we begin this, please make sure you watch the previous video, that is question number 17, because from that video, in that video we have already done synthetic division, synthetic substitution. Now we will learn more about this topic here. Here they have asked to construct arguments. Divide the polynomial function fx cubed minus 10x plus 8 by the factor x plus 5. State and confirm the remainder theorem of this particular function. We will come to this in a while, but first let's divide this. Now, since they have told synthetic division, first you must see whether there is any factor over here, a coefficient. There is nothing. Then we can use this. Here, whatever is given to you to divide, this is the divisor, isn't it? X plus 5. Make it equal to 0. X is equal to minus 5. So this is very important, x minus 5. Looking at this, just change the sign, minus 5, write it like this. What is the other terms? Here we have 4x cubed. There is no x squared, so it's 0x squared minus 10x plus 8. And now let's substitute. 4, first term, 0, next term, minus 10, and lastly 8. Now the thing is, you must always remember something like this. What is that for? Here it comes down as it is 4. Multiply with minus 5, it will be 20. 4 times minus 5 is minus 20, sorry. Now add this up and write it down again. Minus 20 over here. Minus 20 times 5 is positive 100. Add this up, it will be 90. And now multiply 90 times 5. 9 5s are 45. It will be minus 450. And what happens when you subtract? It will be minus 442. Now the last term here, this is the remainder, and you always will have constant term over here. This is constant. This is with the coefficient, the variable of x and x squared. Another way to check is just see the dividend. It's x cubed, so it must be, quotient will be 1 less than that. That's it. So this is the answer. Now we can check our answers. Over here, you got minus 442, same answer. Now, what else did they ask? From the remainder theorem, okay, this is about remainder theorem. This is a remainder theorem that states this, what we got remainder can be easily obtained if you substitute this number over here. What it means is, now we got this, right? The remainder is negative 442. We need to confirm, means check the answer. So directly substitute this part. X is equal to minus 5. Remember, it's not 5, it's minus 5, okay? Substitute minus 5 here. F of minus 5. Instead of x everywhere, it will be minus 5 the whole cube minus 10 into minus 5 plus 8. You can use the calculator and substitute directly, or you know it is 5 cube is 125. Minus will be minus 500. 125 into 4 is 500. Minus 500. Minus. Now, whenever it's square, it will become positive. But if it's odd numbers, negative remains, sustains or remains. Minus times minus will be plus 50. And lastly, what we got? Plus 8. It will be minus 450 plus 8. That is equal to negative 442. And that is what the remainder we got. And that is the answer even over here by checking. So this is what the remainder theorem means. Now, that's the answer. We have confirmed it over here from the remainder theorem by substitution. Same thing. Okay, now this is a reasoning problem. The polynomial function p of x is symmetric in the y-axis. Okay, let's do a simple thing. I will assume this to be, it's symmetrical along y-axis. This must be a, quadratic, something like this. I will just draw a graph like this. Okay, that is not at all symmetric. Symmetric along y-axis means it will be like this, and it's symmetrical. Okay, equal shape. And contains the point 2, minus 5. Okay, my bad. Whatever I did is wrong. I'll do something like this, okay? Now, I'm not sure about this, but it might be like this itself. But anyways, this is more convenient. Anyways, 2. Imagine this is 2. X is 2, and it will be minus 5 here, okay? This is minus 5. This point is there, 2 and minus 5. What is the remainder p of x when it's divided by x plus 2? Explain your reasoning. Okay, what is the x value over here? Minus 2, right? Now we know 2 minus 5 point is there and it's symmetrical along y-axis. So the same point must be there at minus 2 when it's reflected. See, it's symmetrical. So reflection along y-axis over here will be minus 2 comma minus 5. This point must exist, isn't it? It will be minus 2 and minus 5. This one. This and over here. So what you're basically telling is, when you do this, when you divide a particular equation, you will get the remainder of negative 5. That's what we can say. Let's look into the answer. So it's symmetric along y-axis, so it must contain this point. According to the remainder theorem, the polynomial x minus r is p of r when you substitute in the equation, okay? And the remainder, basically when you substitute this r value in the equation, you must get the remainder of negative 5. Because we know over here it's negative 5 and symmetrical along y-axis, so this graph is important. If you draw this graph, I'm sure you'll get full marks. So just draw this graph, it explains more. Because over here, this graph, it shows we already have this point. So it's symmetric on y-axis, so there must be minus 5, minus 2, minus 5 as well. So the remainder is what? Minus 5 here. That's the answer. And over here, see, this is a very straightforward problem. What we just did, on problem number 56. So please do this by yourself. It's just synthetic division. Over here, you have to use root 3, same thing. Don't worry about anything. It's 1 comes over here, multiply. It's like this. Add 3 plus root 3, again multiply right over here, and then simplify it. That's it. Now, yeah, this is multiplied by root 3. Yeah, that's it. See, now if you're thinking what happened over here, I'll just make it clear because I just got a bit confused. You're multiplying this over here and then writing it over here, right? 3 plus root 3 multiplied by root 3. What happens? 3 root 3 plus 3 over here, isn't it? Because 3 root 3 is 3 root 3. So that's why we get this. And add the real numbers together. 5 plus 3 is 8. And now you can verify by substitution. Substitute root 3 over here. You must get this answer. If you substitute, you will get it. In your calculator, you might get decimal point. It's fine. Just check this and this will be same no matter what. And now the last problem here. If x plus 6 is a factor of this term, determine the value of k, factor of polynomial, and confirm the result graphically. Now what they are saying is, this is a factor of this. So doesn't matter, just do synthetic division, direct synthetic division, but keep this as it is like k. And since they have told is a factor, what does this mean? Factor means doesn't matter what, this remainder will be equal to 0. That is the concept. Because now if you have x plus 1 the whole square, it is x square plus 2x plus 1, right? Yeah. Now here I can tell x plus 1 is a factor of x square plus 2x plus 1. Why? Because when I divide this by x plus 1, you can try this later on, the remainder will be 0. Your quotient will be x plus 1, but the remainder will be 0. Whenever there are factors, the remainder is 0. That's the rule. So here x equals minus 6. When you solve like this, whatever the remainder, it must be 0. But we don't know this first part. So now we got the remainder to be 432 minus 216k. That means equate that equal to 0 and now solve. Take this 216 to the other side. It will be 432 equals positive 216k. K will be equal to 432 by 216. And the answer is 2 equals k. This is the answer. Now this is the answer for k, okay? Because the remainder must be 0 and solve it, you got it. Now substitute back over here. Substitute k over here. You can then solve the other factors. Oh, sorry, one second. Don't substitute back over here. That is the question, right? What way do we need to substitute? Over here we need to substitute k. Because the remainder is 0. Now k value is 2. That means it's 2. 15 minus 6 times 2. Minus 77 plus 36 times 2. Okay. Now find what is the, okay, over here this is constant value. Over here you should multiply by x. Over here it will be x square. So the answer will be 2x square plus, because this 15 times minus 12, it will be 3x, and now this you need to put in the calculator. Wait, it's 72 minus 77, it is negative 5. This is the answer. This is the quotient. Because we found the k value, substitute back over here, you will get the quotient. Let's just check the answer. Is that the quotient? Yes, that is the quotient. Okay. Oh, now 1 second over here. I forgot to write it. It's 15 minus 12. It's plus 3x. Okay. My bad. I wrote it wrong. This is plus 3x. Now again you can divide it further, but no, sorry. You can't divide it again because you don't know the other factors. Use the calculator and find the factors. Don't go to do the quadratic formula or anything. Just take out your calculator. We will use mod phi 3 and put the quadratics over here. It is 2, 3, and lastly we have minus 5. And what is the answer? 1 and minus 5 by 2. I'll tell you how to write this minus 5 by 2. X is equal to 1 is simple. X minus 1 will be the factor. What about x equals negative 5 by 2? Answer is this. But when you write factor, take the 2 to the other side. It will be 2x equals minus 5. Take minus 5 to the other side. It will be 2x plus 5. That is the factor. Or there is one more way. X, take this entire thing to the other side. It will be plus 5 by 2 equals 0. Now multiply throughout by 2. It will be 2x plus multiply. See, it's like this 2. It will be here 2x, 2 and 2 cancels, you will remain with 5. The factor will be 2x plus 5. Any method you do, you'll get that answer. 2x plus 5 and x minus 1. So that is the factor. Now if you want to find the solutions, just see over here x is equal to 1. Then over here we had x is equal to minus 6. And what is negative 5 by 2? It is negative 2.5. These are the factors. So that's the thing. Now since we have 3 solutions, what happens here? This is a cubic graph. In the sense, it is a cubic graph. And you can see the k value was positive 2. That means how is the cubic graph? Positive is something like this, right? You will have 1, 2, and 3 solutions. And this is going towards infinity as x tends to positive infinity. Wait a minute, what is happening? I'll write over here the end behaviors. As x tends to positive infinity, the y value or f of x value must be positive infinity. This is tending to positive infinity. Whereas as x to negative infinity, this side minus infinity, f of x or y value also will be negative infinity. This is the cubic graph. So this is the end behavior they have written. And that's it. That's the answer. You can just draw a brief graph. You don't need to draw exact graph. Here you can see this. They have told graphically. That's why I drew the graph. This is somewhat the graph. But here this is not accurate at all. Why? Because it should not pass by 0. There is no solution of 0. One solution must be this. I'll just erase this one. Let me draw some line over here. This must be minus 6, minus 2.5, and lastly 1. Okay, these are the solution. Just draw some cubic graph, positive. So right side goes up, left side goes down. That's it. You can write the end behavior then. So that's it. Please make sure you understand the reasoning problems well. Understand the question, reason it thoroughly, and then try to solve the problem.